Hello, Internet, and thank you very much for tuning into the Cloud Native Islamabad YouTube channel. And this is your co-host for session today on Kyverno Beyond Kubernetes. And this is probably the 47th webinar that actually you're watching from this YouTube channel as well. And let us know in the comment that what are the next set of talk you're actually interested in. And if you're watching us and are the maintainer of the any open source project within the CNCL landscape, do let me know. I'm happy to talk about what you are up to. But today agenda is mostly around policy enforcement and how Kyverno shines very well in this spectrum. Being user and being actually adopting Kyverno early on since 2021, so I love the project and I love where actually is heading towards too. So Kyverno offers powerful policy enforcement capability within Kubernetes, but now you can use Kyverno to validate Terraform files, Docker files, cloud configurations, and authorization request. And you want to learn how, and that's what for the focus of today's session is. But let me introduce, I have four guests of today, but let me introduce one by one with everyone. Thank you very much for being on the show, Anushka. Can you let us know and give us a quick intro of yourself?
I was on mute, my bad. Hi everyone, I'm Anushka Mittal. I work as a software developer at Nirmata. I am a Kyverno enthusiast and I'm really excited to talk about Kyverno-JSON today. Thanks for having us,
Thank you
Simon.
very much. Thank you. And next guest is Addy. Charles. How are you, Charles? Thank you for joining us.
I'm fine, thank you, and happy to be there. I'm Charles. I'm actually not in the best place for this webinar, but yeah, I'm working at Nirmata. I've been working for a couple of years on Kyverno, and I started the Kyverno-JSON project, and yeah, actually other projects that are based on Kyverno-JSON capabilities. So I'm working with Anushka and other folks in this presentation. And thanks for having us, Saim.
Thank you very much, Charles. I will get back to you sooner. So, Nitesh, thank you for joining us today. Can you introduce yourself? You're muted, Nitesh.
My bad, sorry. Hi there, everyone. My name is Nitesh, and I'm currently working as an intern with Nirmata. I'm pretty much excited to be here, explaining about what Kyverno-JSON does, how can these policies be used, and what do we actually mean when we say that Kyverno beyond Kubernetes. So yeah, pretty much excited to be here, and let's see how it goes.
Thank you, Nitesh. Get back to you soon. So, final guest, Faika Ansari. Thank you for being on the show on this here webinar. Can you introduce yourself, Faika?
I hope I'm audible. Hi, Saim. Thank you so much for having me here. Hi, everyone. I'm Faika. I'm an intern at Nirmata, and I have been working with Kubernetes JSON policies for the past few months. And yeah, I'm really excited to be here. Thank you, Sam.
Thank you, Faika. So let's start the agenda with Anushka. Anushka, you actually on the screen once more time. Can you please share your screen and let's talk about the agenda today. So, and between folks, anybody have some question, please put them in the YouTube chat section and we will try to get our first to answer those questions as well. Thank you, Sanskar, for watching us right now. So glad to see you as well. So over to you, Anushka. I think I can clearly see your screen. So my first question for you is, what is policy management in cloud native infrastructure and why it is important?
Awesome, yeah, thanks. That's a really good question, Saim. So let's dive right into it. So, even before I begin, I'd like to take a shot at explaining policy management in a very real life scenario. So, this is how I like to think of it, and I think it's a very apt way to describe and explain policy management to someone who's probably new to it. So imagine what it would be like if you didn't have traffic rules and regulations. Chaos, right? Imagine going to the grocery store, not knowing which side to drive. everyone just going everywhere, no one's stopping for you, and it's just really chaotic. We introduced traffic rules and regulations, and we were able to see uh, to cars and like just vehicles in general following certain rules, abiding by them. If they didn't, we were able to stop them, fine them, and we were able to live peacefully ever after. Same thing. So I hope that made some sense. And let's move to policy management in cloud native infrastructure, right? So policy management refers to some practices, some tools, some processes that help define, enforce, and manage policies. What do these policies do in return? They help maintain security standards, compliance standards. They help with resource utilization, and of course operational best practices. Now this is really cool. This is a lot of things that you get, and given how important security is for organizations and to have security standards maintained in their organization, in their workloads, policy management is very crucial today. So policy management actually can range from security, like I talked about, maintaining security standards, reducing the surface area for threat. It could even go to compliance standards, and maintaining certain compliances that an organization might want, certain regulations that organizations might want. There's also cost optimization where policy management can help, and that's cost policies to make sure you you don't cross certain cost limits, you know what's happening, just maintain your cost structure and make sure nothing goes wrong. There's of course resource management, operational efficiencies, and finally there's governance and risk management. That's a whole lot of things that policy management brings to the table, and that too of course to the cloud native infrastructure. Yeah. So, does that answer your question, Sai?
Yes,
Yes.
perfectly fine.
Awesome.
That's perfectly answered that as well. So I think, Anushka, anything you want to add before I move to the charts to talk about how Kyverno can do it for outside Kubernetes?
Yeah, no, that's good. I'm actually very interested and excited to hear Charles speak next. Let's go.
Okay, Charles, over to you now. You're visible on the screen. So I think I'm super excited to finally able to tell people that you can use Kyverno beyond Kubernetes. So can Kyverno be integrated with non-Kubernetes platform and or non-Kubernetes cloud resources? Over to you, Charles. Charles, you are muted.
I'm mute. Okay, sorry. So better now you should be able to hear me. Yo. So yeah, the answer to your question is it is now possible to integrate something similar to Kyverno outside of the Kubernetes world and to extend the capabilities of Kyverno beyond just Kubernetes. Actually, this is something we worked on last year and that we announced in KubeCon in Chicago at the end of 2023. So this is a pretty young project, and it was all inspired by customers' requests because a lot of users wanted to use Kyverno outside Kubernetes, like for infrastructure as code or other things. But they used Kyverno, they loved Kyverno, they loved the simplicity of Kyverno, the way to write complex rules with a couple lines of YAML, and that almost anyone that is not really comfortable with programming language, but that knows a bit about Kubernetes or about Helm can write policies. they liked this simplicity and wanted to be able to use the same concept or something close or similar outside of Kubernetes. So of course, when you look at the Kyverno docs, it's clear that Kyverno is only for Kubernetes, and it's written in bold. It's designed for Kubernetes. And so we had to keep what makes Kyverno an excellent solution, but also remove the limitations that are Kubernetes related or Kubernetes centric. And for that, so oops. Uh, if we look at Kyverno policy, so probably most of the audience knows about Kyverno, and if you don't know, a Kyverno policy is just a simple object. The root object is the policy itself. A policy is made of rules, and then these rules is going to match resources. So in the Kubernetes world, it can be a config map, a pod, a deployment, a secret, a custom resource, anything that lives in a cluster. And to do that, you have match and exclude statements. And then you have the content of the rule itself. So we have validation rules, mutation rules, generation rules, image verification rules. So that's how a policy is built in Kyverno. And the first thing we wanted to address is, okay, in the match exclude statement, we have things that are very Kubernetes specific. We have namespace. Namespace only exists in Kubernetes, but if we take Terraform, for example, there's nothing like a namespace. A kind doesn't exist in Terraform. It's something that's specific to Kubernetes. Labels, annotations, cluster roles and roles, groups, service accounts, everything like this is very Kubernetes specific. So we had to find a solution to do the same thing, but different. And that's how Kyverno-JSON ID was born. And if we look at the policy in Kyverno-JSON, so let's take this one, for example. This one has a match statement, and the match statement has any, which is at least one of the conditions must match. And instead of having a kind or an API version or a name or a set of labels or things like this, we just have a type, a key, and the value. And the key and the value just must match, but it can be really anything. It can be, I don't know, a type. For this one, this is an AWS ECS cluster, so it's a policy for a Terraform reset. It can be something different, and of course, we could have kind pod. It could be another option, but it just doesn't make sense in the context of a Terraform policy. So yes, to answer the question, it's now completely possible to use something like Kyverno. It's not exactly Kyverno, because taking the exact syntax of Kyverno policy and uses that outside of Kubernetes cluster wouldn't make sense. But actually, it is completely possible. And the way we are going to evaluate a policy against a resource will necessarily be different too, because Kubernetes has an admission controller. You can register a webhook. You can plug your own logic in the Kubernetes API server. If we talk about Terraform, there's no API server. If we talk about Dockerfiles, there's no API server. So the plumbing is different, and the syntax had also to be a little bit different. And eventually, the storage will be different, because if we talk about Terraform or something else, of course, there's no etcd storage. So it could be something different. If we talk about CI/CD, the policies can be stored in the repository itself. So the storage and the way Kyverno-JSON is invoked also depends on the technology you want to apply the policy uh, to, but you have to, yeah, sort of provide the storage and provide a way to invoke the tool.
Thanks, Josh. Thank you. I will get back to you as well because it's really delighted because a lot of the time when I'm speaking and outreaching Kyverno in the public side, a lot of the question from customers' point of views and the company's point of views and some community point of view is I want to use the same set of features that Kyverno providing me outside of the Kubernetes. How do I can do it? So for the long time, we don't have any answer to this. But as of you speaking, we have some answer. And that answer requires to understand how the Kyverno and Kyverno-JSONs work. Because at the char speaking, in the Kubernetes, outside the Kubernetes, we have different resources that can tackle these kind of syntax. So we, in theoretically, we need to come up with the new syntax as well. So as you mentioned, Charles, during the conversation, that how to write policies. So now I'm going to FIGA to understand how do Kyverno is different from other or compared to other policy enforcement tool. So over to you, FIGA.
Yeah, I have been everyone. I hope I'm audible. Okay,
Yes, I
so
can
how
hear
is
you.
like Kyverno JSON different from all the other policy management tool? I hope my screen is visible. So like Kyverno, we all know what is the impact of Kyverno. So I have like a pretty good slide. So we know the impact of Kyverno in the world of Kubernetes, how it applies to the Kubernetes cluster and how it is um, Kubernetes native. It makes policy results very easy to process, and all the amazing benefits that Kyverno has in terms of security for Kubernetes, right? Similarly, when it comes to why we use Kyverno, it makes writing policy for Kubernetes easy, and at the same time it makes results processing all of these things much easier. You can mutate your policies, generate, and all the other things that Kyverno has to offer, correct? Similarly, like in this aspect only, we got Kyverno JSON, which is nothing else but beyond Kubernetes. So Kyverno beyond Kubernetes. So we do not just talk about Kubernetes now, but all the infrastructures that can be written as code. So which comes like which you can talk about IAC tools like Terraform files or Docker files or anything like that sort of. So all of these ISC is where Kubernetes JSON can be applied to. So that is like a major difference between Kyverno and Kyverno JSON. Kyverno was Kubernetes native, and Kyverno JSON can now be applied to all of the ISC infrastructures. So yeah, that was the major difference between these two. But how does Kyverno JSON like stand out? So obviously, it applies Kyverno policies everywhere. So this is like the main website, you could say, UI, if you want to explore what Kyverno JSON is. So you can apply Kyverno JSON policies to all the IAC codes. And the best part is that writing it is very simple, and it can process any JSON and YAML payload. So how do we create the JSON and YAML payload will also be discussed in the later part of the same webinar, and it will be really cool and easy. I hope you all stick towards that. And yeah, so using Kyverno JSON, you apply it to the CI/CD pipelines, your IAC, and all those things. So there's no complexities, and this is where we are currently on this major release. There is a simple documentation here, and that's I think about Kyverno JSON, and I hope that answers your question, Charles. Same.
Yes, absolutely, perfectly well. So now I head over to Nitesh so he can speak about because as of now we're speaking about that there is a Kyverno that is native to Kubernetes and we know how to write policies and that is YAML based. And now we're speaking outside and that's outside what are the different way to write policies that is known Kubernetes based platform. So over to you, Nitesh, to give us a walkthrough of that.
Sure. So I'll be sharing my tab. All right. As Faika mentioned about Kyverno for JSON, I'll be telling about what are like what about the policies that we have written for Kyverno-JSON? Of course, the Kyverno policies, you can head over to the website and you will find the policies for what Kyverno does. But if I talk about the Kyverno-JSON policies, if you go to the Kyverno-JSON website, you have a section for the policies here. And definitely you will see that these policies have been written, but wait, there are a lot more policies that you can explore. Example, if I just pick any of it, example, Dockerfile expose port 22 not allowed. Now, what happens in Kyverno, since it's Kubernetes native, you eventually, it is bound to work only for the Kubernetes. But now we are trying Kyverno to extend beyond Kubernetes. So now this is a Docker file that you have written, right? Imagine you have exposed any port number 22, while writing a Docker file, which is not a good practice. Why? Because I think it's an HTTP port, right? So that this policy is going to check if in your Docker file you have port 2022 expose or not. So it's going to see your Docker files. It's going to check whether you have 2022 port exposed or not. If you have exposed, the policy will give you failing checks, else passing checks. Similarly, we have a lot of other policies here as well. For example, AWS ECS, then this is related to Docker file, then this is related to again some of the AWS. That being said, these are not the only one. If you head over to something like github.com/nirmata/Kyverno policies, you will find a bunch of policies here as well. And I would personally refer to policies something like cloud controller/crossplane/AWS. If you go through the AWS, you can find that we have some S3 and ECS. If I go through S3 one, and if I see these are the policies that are for the S3 policies. Similarly, I have, if you go through AWS again, you will have the policy for the ECS. If I go about anything, this policy is going to check something related to S3. It's going to check your bucket logging, whether it's enabled or not. So yeah, I mean, just refer to these two links. First, the Nirmata/Kyverno policies, and just head over to cloud controllers and cloud controller/crossplane/AWS, and that's where the AWS policies lies in. But wait, we have covered upon the cloud configuration like AWS. We haven't taken a look at where are these Docker files, but how do you use these policies? How do you write these policies? Will actually be very interesting, and we'll be talking about that in demo. But yeah, as by now, just go through the Kyverno-JSON documentation. You'll find a bunch of policies there, and just go through this GitHub repository. I've shared the link, and you're good to go. I mean, yeah, that's it.
Thanks, Nitesh. I'll get back to you for some of the demos part as well. So, Charles, I think you are now in good position. I hope you can able to hear us. And you're muted. Can you please unmute yourself? So, I think we spoke about correctly, as you mentioned in the previous conversation. I think somebody is on the diehard fan of the Kyverno. They wanted to understand, like, using Kubernetes, you can actually enforce or you can actually prevent bad vector to deploy into the cluster. But now its policies is outside of Kubernetes. So there's a new sentence into it. And how those Terraform cloud resources or Dockerfile. So what are the different ways you can write policies for those and how to enforce it? What are the different ways to enforce or validate those policies that outside Kubernetes?
Okay, yes. I hope you can hear me well now. I'm going to try to share my screen again. Not sure, it's not a good one, but hey, that should be good. So if you look at the Kyverno-JSON, documentation, we have a couple of solutions for that. Of course, it's a bit more difficult than what you can do with Kubernetes because, as I said earlier, there's an API server, everything goes through in the end, you register your webhook and the API server delegates the validation, the mutation, the generation, or anything else to your own implementation. This doesn't exist in most of the other technologies. So we first have a command line tool, which is the basic and probably the most basic solution, but it works for most of the use cases. Like with the CLI, you can verify your policies in CI/CD pipelines, for example, and you can accept or block a pull request if you detect violations in the code that is in the pull request. So it's a first solution. Honestly, it already brings a couple of good solutions. Another solution is to use Kyverno-JSON as a Golang library. And then if the CLI doesn't suit your needs, maybe I should talk about the other option. The other option is to deploy Kyverno-JSON as a web application. So you can deploy Kyverno-JSON as an API, and then it's just another API. You send your resources. Eventually, you say send your policies, and the API will tell you yes or no. The resource you are sending is valid against the policies you are sending. This API can be deployed in a Kubernetes cluster, and if you deploy the API in a Kubernetes cluster, you can leverage all the advantages of Kubernetes clusters, like you can register the policy custom resource definition, and then you can create the custom resources corresponding to your policies, and the API will automatically use that as a storage. So it's basically a storage problem. And this can be solved using etcd and the capabilities of Kubernetes clusters. Ultimately, if using a CLI or using an API doesn't suit your needs, we also provide Kyverno-JSON as a Golang library, and you can use the Golang library to integrate Kyverno-JSON in your tooling, creating your own tool adapted to your needs, adapted to your new technology. Like, let's say, for example, you need something very specific because you're writing something that is not in JSON, that is not JSON native. You can take the Golang library, you can take your file format, convert this to JSON, or convert it to a pure Golang object, and from that you can apply policies. So we have a solution out of the box based around a CLI or an API. And if it's not enough, you can also take Kyverno-JSON and build something with it. So it's truly open source, and it's extensible in different ways, actually. So, for
Thanks, Charles.
example,
Thanks, Charles, for
okay, some folks use it in GitHub Actions to validate PRs. Some other folks use it on a cron schedule and things like this. Some other folks integrate it in their application directly, and they use Kyverno-JSON as a library, and they can directly validate, for example, their Lambda functions using Kyverno-JSON at startup.
Oh, great. Absolutely. So I think there are some more use cases here, but that's very wonderful in theory as well, because a lot of the Terraform resources create some resources in a lot of the Terraform file create resources in the cloud that has some limitations in it. So one of the way you can actually enforce that whatever has been deployed into the cloud has pretty much permissions model issues or has been some validation issue that can done now with Kyverno nature of with Kyverno-JSON. But I will definitely get back to you, Charles, to understand what is the next few steps for this project as well, because there are some wonderful use cases into it as well. So now I'm heading back to Anushka. So she can talk about some of the real world use cases for using Kyverno-JSON. Over to you, Anushka. I'm getting back to you.
Hello again. So, is my screen visible?
Yes, I can see it now.
Awesome. So yeah, Charles really covered, how Kyverno-JSON can be used, and we understand what Kyverno-JSON is and how cool it is, and how it can really address some of the most concerning issues in a lot of places today. In the next few minutes, I'll try to show you one of the real world use cases that we help with, and you could probably use in your organization, and at least experiment with. So that is actually a shift left workflow. So when we talk about shift left in security, we talk about including security guardrails at an earlier stage in development in your CI/CD pipeline, right? So usually, in an organization, the people who set up the CI/CD pipeline, get all the configurations in, uh, are different. They're like the DevOps people, and then there is a team. There are a couple of teams, maybe the platform team or the security team, that takes care of the policies, sort of ensures how exactly the security posture of the organization is managed. Now, what can happen with Kyverno-JSON today is, the platform team independently can store policies in a central policy storage, and the DevOps team can independently set up the CI/CD pipeline. What will happen in between, like you see here, is, in GitHub, we'll set up a GitHub action that will pull these policies from a central policy storage and scan the configuration set up by the DevOps team, and let you know if there are any misconfigurations. So, yeah, that's what will happen. Let's maybe quickly look at how it will happen, right? Let me take you to this dummy repository that has a folder for configuration files that contains uh, some configurations for Dockerfile, Kubernetes, Pulumi, Terraform, and I also have a directory with controls. This essentially has all your policies that was set by either the security team or the platform team, right? What I would do next to have this shift left workflow is I will define certain workflows in .github/workflow that would run on a pull or a push to the main. So, what do these workflows try to do? The job essentially tries to get Kibana JSON action, check it's installed correctly, and finally scan your config files with whatever controls you've set. And if, of course, something fails, you'll see your pull request failing. What will happen now is that when your DevOps team creates a configuration file, before it can be merged and really put in your workload, it will go through all these checks that will ensure that it's not violating any controls that were set by other teams, other policy enforcement teams, like your security and platform team. So let's see, just real quick, what it would do. So I have a payload.json, um, from um, a Docker file. This is a Docker file converted to JSON. Let's take something that's a little easier on the eye, right? Let's take a Kubernetes deployment. What I want to do is add a configuration file and get my actions running to see if something's failing or not. So, or I'm going to change something super simple, nothing to create, maybe just the number of replicas or labels. Let's just change the number of replicas, commit the changes, uh, create a new branch, post changes, and go back to create a pull request. Great. So as soon as the pull request is created, you'll see in a couple of seconds all the workflows that you had set up to scan your configurations will start running. They'll probably take a few seconds to finally run and show if the configurations in the pull request under question are failing or passing. And yeah, there you go. So you have the Kyverno scan for Dockerfile failing, you have the Kyverno scan for Kubernetes failing, and the other two are passing. Maybe I can take a quick second to show you what it looks like. The job ran, and yeah, the Docker file failed because it was violating one of your copy over add policies. And you'll see the Kubernetes scan failing because the Kubernetes resource in your configurations was violating the disallow host namespaces policy. Awesome. So now this would essentially force the author of this pull request to go back, change the configuration, and sort of correct it to match the policy or the security requirements of the organization. Coming back, that was a really quick dummy workflow of what Kyverno-JSON could do for you, apart from the many more things that it can do. Of course, needless to say, Kyverno-JSON and Kyverno are available as GitHub Actions on the GitHub Marketplace. And yeah, some really cool and fun things can be done with it. This was one of the real world use cases that I thought we could talk about today.
Thank you very much, Anushka, for some very good insight into this, some how we can actually leverage Kyverno-JSON for some of the production issues we got having in Terraform setups or Dockerfile or authorizations requests. And now I head back to Nitesh and Faika to actually able to give us a walkthrough around some software catalog, playground, and bunch of other things that is Kyverno providing. So over to you, Faika. So give us some
Oh, okay.
virtual tour of some other things that Kyverno has. Over to you, Faika.
Awesome. So, yeah, hi everyone again. And talking about the policies that we write and how what does the policy catalog look like. So you can basically head on to the same website that I mentioned earlier, kyverno.github.io/kyverno.json. And this is where you will find the UI version of the policy catalog. So we use the Kyverno-JSON, which is a CLI tool using which we run these policies against the JSON or YAML payload. So this is what the policy catalog here looks like. So we have policies for AWS, AWS infrastructure or Dockerfile, so all of these things we have policies against these. So if you go through these policies, there is an exhaust some of the policies can be found here, and you can at least have an idea of what the Kyverno JSON policies look like from the policy catalog present on this website. But this is not an exhaustive link. So if you wanna view all the policies, we also have a lot of policies coming from Terraform and Dockerfile, which you can find listed on the Kyverno policies repository. So this is somewhere here, and I'll just go through some of the policies that we have written previously. Like for example, this one. So it's like a policy which is basically checking the that any AWS in an AWS cluster, is the AWS network mode, VPC network mode is enabled, or is it some other network mode. So if you check the policy, this is what it looks like, and we have a policy structure. This is we have several tests running, and this is the whole thing over here. And all these whole bunch of things will be present on the UI under the policy catalog. So you can quickly run through the policy catalog and check this in your own cluster by just running these simple commands. So you have to install Kyverno JSON CLI tool and run these manifests against the payload, the or your infrastructure that you want to run this against. So it is about it. I think we also have a playground where we run these. Ritish, would you want to talk about the playground more?
Sure, I can talk about that. So what happens with the playground is that let me try to. Okay, so we're going for a demo part, right? Of course. So if you go to, let me do that really quick. Um, JSON. Okay. Yeah. All right. I mean, yeah, we do have a GitHub repository as well for the Kyverno-JSON. But if we go through with the website for the Kyverno-JSON, so if we go down, you can see that there are the documentation is available definitely and if I go through the documentation, we can get redirected to here. Cool. We do have a playground here as well. So when do we use playground is a thing here. Okay, let me just click here and you can see that it redirected me to here. Now you can see there are two things: input, which is in the YAML format. Don't worry, you can also put your input, which is a payload, right, in a YAML or a JSON format. And here it will be your policy context, right? And then your policy is going to get matched with your whatever the input you have provided. Okay. Now your question might come is like, okay, if I want to write a Docker file, how do I write it? How do I put the Docker file here in the YAML or the JSON format? Eventually, you need to convert your Docker file somehow to JSON, and then you put that content in the input, right? And then you return, and then you run that policy, whatever will provide you against that JSON payload, right? And based on that, whatever you want will give you passing or failing checks that will be appearing in this output window. That being said, before we tell you how to do that, let's see how do we write the policies. How do we write the Kyverno-JSON policies for that? But yeah, this is basically Kyverno-JSON playground. It's always recommended that whenever you are trying to write your own policies, which I think Faika will be telling you about how do we write these policies, so which you can also get to know about how do you write your own policies. So when you get to know how do you write these Kyverno-JSON policies for your own need, right? It's always better that you always test it on playground rather than testing it locally, because sometimes there can be version compatibility. Something might not be. Sometimes things might not be going in a specific version. So it's always better that you test it on the playground, and that's going to give you very simple results. So yeah, I think Faika, you can go ahead and start telling them about how do you write the Kyverno-JSON policies. Um, yep.
Oh, okay. So, how do we write policies? I would first need a payload, obviously. So, when it comes to writing a policy, like obviously, because we are writing it against an infrastructure, so that infrastructure is an IAC, which can be written as code, and we first convert it into a JSON payload. How do we do that? So, there can be several ways to convert your AWS infrastructure or your anything like your Docker file into a JSON payload. There are several ways to it. Like what we use, like for example, for AWS infrastructure, it is written in Terraform file. So we simply convert that Terraform file using the Terraform plan command into a JSON payload. So use the Terraform show command, into a JSON payload. So I would just pick up a payload, which is not something to talk about right now. We are going to learn how, like, we're going to see how we write the policy. But to talk about the payload, it is basically generated through any of the IAC. You can convert it into JSON or YAML. So let me get a payload. So where am I getting this from? So we have like I said already, we have this repository Kyverno policies where we have a lot of examples and a lot of policies already present there. So I might just pick one policy from here or a payload from here. So this is a payload, and on the playground, it's very simple. We're just gonna paste the payload. So this is one of the AWS infrastructure, which is AWS ECS task definition file. And now we are going to try writing a policy against this. So it's very simple. We have the website, Kyverno-JSON website, and there the entire the format of how Kyverno policies are written is mentioned. We obviously have a similar structure like an API version, which defines the version of thing we're using. So in this case, we use json.kyverno.io. I would just go on using, and right now we are at the V1 alpha 1 stage, so I would just simply go ahead with writing that, and that's how we work with it. So oh wait, yeah. So that's the basic infrastructure, and now the next part would be mentioning similar keys and value like kind, the metadata, and the name, the label. So it's like something very similar to it. So I would just pick up a policy and show exactly how those sections are written. So that's what it looks like. This is a validating policy that we are writing. The metadata has the name of the policy, and we also obviously have some labels. And I hope all of us know all of these sections because this is very similar to how Kyverno policies were written. So I think I should simply jump to the major part which differentiates Kyverno JSON policies from Kyverno policies is the spec rules section. So what do we have here is Kyverno JSON policy is written with the help of JMS path expression. So if you see the check has this JMS path expression, which is doing nothing else but fetching the value that we want to talk about in our policy. We want to validate in our policy. So currently, Kyverno JSON is particularly about validating. And in this policy, if you see, we are trying to validate if AWS VPC mode is used or not in this ECS service. So this is a JSON payload that I obtained using simple Terraform command and Terraform CLI tool, and this is the policy running against this payload. So if you see, let's just try to see exactly what is happening here. I think I should use JMS path expression. There's a like really cool website where which we take a lot of help from. So I mean, I could actually add over here. This is what makes Kyverno-JSON so developer friendly. You do not have to, know a lot of code. Like we have a lot of other policy managers, like be it OPA, Chekhov. They are all like written in Python. But in case of Kyverno-JSON, it is so low code that anyone do not need a lot of engineering efforts to write these policies. So that is like one of the best use case of having Kyverno-JSON. So it's simply written in YAML format, and we use JMS path expression. So here I have the payload, and let's see what exactly this check is doing. So I would simply copy this check and paste it here. So you see that this is basically narrowing down an entire payload to the section that we want to focus on. So now what it's doing is it went down to the planned values and then moved down to root module, the resources, and resources with the type ECS task definition, and then comes values. So this is where we are under values, and now even under values I want to check basically the network mode. So here is the network mode, which is set to bridge, which should basically fail the infrastructure because we want AWS VPC mode. So what do we do here? We basically like where is my screen? Yeah, so we basically move even down and we would check for the network mode that this has. So like going further, yeah, so there we have. So we have the bridge network mode, and that is basically how I am fetching the value that I want to see or maybe check in the payload, and that's how Kyverno-JSON works. It's as simple as that. Now I have the value bridge mode. Now it will just check that bridge mode that we saw was fetched over here. Let's just see where the bridge mode is mentioned in this payload. Yeah, over here. So the network mode is bridge, and here we're checking that, and the network mode we want is set to be AWS VPC, and this payload should fail. When you run this policy, you see it is failing. And in case I set this to AWS VPC, this should be passing. So that's how simple this policy is. Like you just can apply these policies to your IaaS infrastructure. And yeah, I think that pretty much covers and helps a lot of us. So Kyverno-JSON is the CLI tool which you can use in your own computers to test this, write these and everything. I think, yeah. Over to you, Sam.
Muted, I guess. Thanks, Nitesh, and thanks, Malika.
Thanks, Nitesh, and thanks, Malika.
And I really like the demo. I really like the demo you actually showed today. It's really how easy it is. And I really like the recent addition of Playground that basically give you some dry run commands. So you're making sure you are not spinning up infrastructure on some customer resources. You have to deploy some stuff locally or in the playground somewhere just to understand the behavior of this policy is. And that's where the playground really shine as well. And then the FICA shows you how easy it is By using the James pass expression, you search out the value and block or pass the policy based on that need as well. So thank you, Nitesh, and thank you, Faika. Now I head over to the creator of this project, Adi Charles, to help us understand like what is some next set of features coming up next. So over to you, Charles.
Hey, uh, I'm not mute. That's okay. I
Yes.
hope you can hear me. My network conditions are not very good, so I won't share my screen. I think it's better. Of course, we have new features planned and a big roadmap. As I said, it's a very recent project. We worked on it last year and unveiled this project a few months ago in Chicago. So the project is going to evolve. Probably the most significant feature we want to add is mutation support, because right now Kyverno-JSON is only about validation. We have a prototype to support mutations, and I hope it will land in soon. Another thing we would like to add, but we didn't really have the time to work on it yet, is to support cell expression language. Kubernetes has adopted cell, the cell language, so it probably makes sense to adopt it too. And today we are using GemsPass. GemsPass and Cell are very similar language. They are side effect free. So basically, supporting one or the other should not be too difficult. And of course, we want to receive as much feedback as we can. So we created a tool that's called Chain. So this tool is today used for end-to-end testing. It's a replacement for another tool called Cuttle, and we worked hard to get Chainsaw adopted in the community. The feedback we received was incredible, and it helped a lot designing the future of Kyverno-JSON. We are building an Envoy plugin around Kyverno-JSON to run audit. And of course, the idea is to integrate Kyverno-JSON in Istio and other service meshes. So I will be at KubeCon next week. I will meet with Kuma folks, with Traffic folks, and the idea is to allow implementing Odzi in Istio and other projects based on Envoy using Kyverno-JSON policies. And yeah, I think that covers pretty much it. We have other plans like integrating in a more high-level tool. Kyverno-JSON is really a mix between the tech and a product. So we have a CLI, we have an API, but we don't have anything opinionated. So Kyverno-JSON itself doesn't decode the Docker file. You have to decode the Docker file into a JSON format to be able to validate it with Kyverno-JSON policies. So we are also building a more opinionated tool on top of Kyverno-JSON that will have the features to decode specific file formats into a JSON payload and to pass this payload to Kyverno-JSON. So yeah, that's probably the best user experience, because Kyverno-JSON is really an hybrid between technology and product, and building a project on top of Kyverno-JSON is definitely the next step.
Yes, I'm super
That's
excited
it.
to see.
I hope I was. I hope I was.
Yes. Yes, Charles, I think you're having some issue, but thank you very much for actually giving us some grounding side. I think you're very closer to the KubeCon as well place. So thank you very much. So actually, for the last question, for all of the folks that joining me. Thank you very much. I think it's late, but thank you very much for joining us all. So, who will be at the KubeCon next week in person? John is already there. Natesh, you are not going there. Good.
Not this
And
time, probably.
who will? Okay. And who will be presenting talk or anything that's related to Kyverno? So, Anushka, can you
Okay.
tell us what was it is?
Yeah, so I have a talk coming up. It's actually called How I Met Your Software. I'm pretty excited about it. It's going to be a little dramatic, and I'll probably be covering parts of how Kubernetes can help secure your software when it's active in your workload, and the different ways you can use Kubernetes to do so.
And Faika?
Okay, so my talk is basically around Kubernetes, and it would be about a repository that I'm maintaining at Kubernetes and how stakeholders can use that repository to basically predict a lot of the changes in their cluster.
And anyone from
Are
you,
you coming?
I believe this time I won't, but I love to. But this time I'm
Okay,
missing. Me and Atish will be actually on the e-meet, style of attending the conference. But
virtual cube.
anyone from you is actually in the Kyverno booths. I believe there are some booths for open source project.
Yeah.
Who will be there?
Yeah, so really, we have quite a few members from the Kyverno team, some maintainers and contributors, and there is, of course, folks from the Nirmata team as well. So, yeah, we'll see you there. I'll be there, and I know Faika will be there as well. Charles, of course, and some more interesting folks.
Yes, got it. Thank you very much. I saw it's very late for you, but thank you very much. It's been a wonderful learning for me as well, and looking forward to see how the audience will behave to this webinar as well, and looking forward to your question as well. So, just a final question for everyone: what next is exciting for you coming up in Kaiwan? Everyone. So, Anushka, for you.
So for me, I'm really looking forward to how Kyverno-JSON expands in terms of mutation and adding more features. It's really in its early phases of development, so there's a lot more exciting things to come, and I can't wait to actually come back here again and talk about it super soon. And another thing that I'm involved with is an Envoy plugin with Kyverno, so that's in the works as well, and I'm excited for how it turns out.
Okay, and Faika.
Yeah, okay. So obviously, like currently, Kyverno is in an early stage, like Anushka already mentioned, and we are the team working on Kyverno-JSON. So I'm like really excited to bring up more policies to Kyverno. Like currently, we have AWS, ECS, S3 bucket policies, and we also have Dockerfile policies. So I'm looking forward to writing a lot of policies and seeing a lot of people contribute to this like really new thing coming up. And I'm very sure a lot of people will be very excited to add this to their infrastructure since it's so cool and so easy that anyone can just have it. So that is the most cool part and most fascinating part to me. And yeah, I think that is it.
And for Natesh.
Yeah, yeah. I mean, you already know that Nirmata is the creators of the Kyverno. So what I'm really excited about is probably something expanding Kyverno JSON more such that we can have our own CLI tool, such as maybe Nirmata CLI tool that you can use on the top of Kyverno JSON and probably do everything. Maybe convert JSON, Docker files to JSON, any payload to JSON, and then use one single command, and that's going to test your payloads. And probably some automation on the way, such that some text appears, some like ChatGPT stuff. You put a problem, you put a policy, and you get the results out of there. Why is this policy working this way, or what is this policy going to do? So yeah, pretty much excited stuff for the future, and we're really looking forward to that.
Thank you very much, everyone, for actually joining us on this episode of the webinar and making sure you head over to kyverno.io for write policies and enjoy policy and restrict bad vectors to get deployed onto the production setup. And with Kyverno, now you can use Kyverno policies to validate Terraform files, Docker files, cloud configurations, authorization requests, and more. And with that, we'll be meeting you again with another webinar. Have a wonderful day, everyone. Bye bye.